guys. This is to walk you through the sampling key points for Unit 5. The big things to consider as you're thinking about your own research design and looking at others is this question of what was the population of interest? In other words, the larger group, the overall general group of sites or people that the researcher is interested in. And then the second question is, did they get the proper subset of observations from that population? Are they building a tiny model of their data? Is one way to think about it. It represents the larger group that they want to draw some inferences about or learn about. The sampling relates to all studies or site participant selection, if we want to think about it that way. Different goals and different language for qualitative, which is more descriptive and exploratory, versus quantitative. Especially inferential statistics, where we're really trying to make some predictions or have some inferences that we can count on being true consistently for other parts of the population. So I might grab some data about some schools in Denver, and if I pick that group of schools appropriately, it may be that I can draw some conclusions that I expect to also hold true for schools elsewhere in Colorado or perhaps elsewhere in similar urban settings. Qualitative designs, we tend to refer to site selection or participant selection. The idea here is just to identify where I'm going to find sources of data that are relevant to the research question. So this isn't so much getting a representative sample, something that I can draw conclusions that I expect to be true elsewhere. That isn't really usually the point with qualitative work. What I am making sure that I do here is that I get the right kinds of sources for my research question. So, for example, if I'm doing a phenomenology about what it means to be a brand new teacher, I would not want to select brand new technical engineers or IT people or business majors, because obviously those people aren't going to know anything about what it means to be a new teacher. Quantitative designs, we might also want to make sure that our data are representative. Now, representative is one of those terms in stats, like significance, that has a particular technical meaning in addition to just the general English language version. We really want to know that our data are pulled from that population of interest in predictable ways so that we can make some inferences through our statistical tools. Again, to think about that as kind of a model, a mini version of the larger population. So my first step in all of this is to define my population. Who am I interested in learning more about? What am I interested in learning more about? Then I determine the sampling frame. The sampling frame, as stats speak, for defining those things that we think might be most important related to my research question that I want to attend to when I'm sampling. So for example, right now we're doing a time study with Denver Public, and we decided things like we need some representation of elementary, middle, and high schools, because each of those has a very different time-related setup for teachers. We want to look at union schools versus non-union and locally flexible schools, because again, that's related to our research question. We can select the sampling techniques. This comes down to what you want to do with the data. So it may be that we can just have a convenience sample or like a qualitative sample, because we're not trying to generalize what we find. It also had to do with how accessible the data are. So sometimes we'll talk about a general population or population of interest, and then we'll also talk about the accessible population. So an example there might be I'm interested in all students in schools, but I only have data accessible on students in public schools, not private schools. So my public schools become my accessible population. And then I have to make some decisions about what does leaving private schools out, how does that affect or matter to my research question? Maybe it will, maybe it won't. Other types of sampling techniques get down to just kind of the nitty-gritty of what's feasible, what's affordable, how can I get to the sample, the ideal sample that I might want. Then we're going to determine the sample size. So the sample size really is, again, a real practical idea of how many test cases, if you want to think of it that way, how many respondents do I need, if it's a survey or assessment or something along those lines, in order for me to do the reliable statistics that I need to do. We'll get into that in a minute. And then we grab our sample. So again, got the little model plane there, but that's the idea on a random sampling. So through the simple random sampling, we're trying to generalize the attributes of the population. The big idea here on the random sampling to let us do the inferential statistics is that everybody in the population of interest has an equal chance of being picked in my random sample. So that's the technical term of that representative sampling. The reason that this, and sometimes we'll call it probability sampling, the reason that we're interested in this equal probability is that we can do the inference. If I know that I've got a randomly selected sample, I can make the assumption that, given a large enough sample, that I can be precise in what I find with the data that I have probably being true for the population, for the data that I don't have for the rest of the population. Another important concept to think about here is that when I'm randomizing, one of the things that I'm doing is really, by picking a random sample, I'm making it likely that anything that I haven't already thought about that might be related to my research question is equally distributed in the sample that I've grabbed. So I don't have to worry about thinking of every single thing because that random selection, for example, perhaps unbeknownst to me, being a new teacher changes, that experience changes depending on how tall you are. If I picked a random sample of teachers, I'm going to have short teachers, I'm going to have tall teachers. They're going to be distributed at random, and they're going to, that effect of height that isn't part of my research question, and that, but does relate to the way teachers might respond to a survey. I don't know why, but maybe it would. Because I've got short and tall teachers kind of randomly distributed, it'll all cancel each other out, and it won't impact my actual research question data. So this all lets me have some confidence in the estimates that I'm making for the population. Again, if I'm not concerned about generalizing to that larger population, I don't necessarily need to do this probability sampling. Simple random sample design is the most basic. It's the first one, the ideal that we start with. It can be challenging in practical application because you have to know where every member of the population is. You have to be able to get to them. You have to have a way to select them. Sometimes folks will do a version of random sampling called systematic random sampling. So, this is kind of a count-off. So when I have, say, a list of all the teachers in the state, I might take every 50th. I just decide which population, what sample size I want, then I can do that counting. As long as there's no particular bias in the way that my list is organized, I can do this simple random or systematic random sample and get very similar results to a true random sample. Stratified random sampling, this is where I want to make sure that I've got particular subgroups. So my example earlier when I said, well, we wanted elementary, middle, and high schools, I group my population into those subgroups, and then I draw a random sample of elementary, a random sample of middle schools, random sample of high schools. If we were to go back to our data set from Unit 2, the example might be, well, I want to group by religiosity, how religious folks are, and I want to compare it to the rest of the I can have disproportionate random samples too. In other words, I draw an oversample. You'll hear this sometimes when I have a very small subgroup. If I say I'm interested in all of the various ethnic subgroups in a population, but I know that I only have 3% Native Americans in the area. If I'm drawing a sample of only a couple hundred people, that's only going to be 6 people in that. It's not enough to represent that subgroup. So I may want to oversample. As long as I know what that proportion is, then I can compensate in my statistics. Cluster sampling design. This is where we're intentionally grouping into heterogeneous clusters. So I don't have specifics enough about the population, or they're too complex for me to break everybody into the subgroups that I want. But I do have some pre-grouped, like schools or classrooms or cities, I have some pre-grouped sets of population, of the population, where the complexity and the mix that's within that set is likely to be like the rest of the population. So I can pick some classrooms, for example, sampling those clusters, sampling the classrooms, each classroom being a cluster of participants, and then draw conclusions about other classrooms because I have an adequate representation of types of classrooms. This can be a really cost-effective method too, and efficiency, since it doesn't make sense to go in and just survey a couple of kids in each classroom. I can survey the entire group of the classroom and get my data that way. Now, when we're not doing the probability sampling, the non-random sampling, is often used when it's convenient and cheaper, when I don't care to generalize from the sample to the population. I can still learn a lot. The difference between the generalizing versus just learning something, I can learn something about the phenomena of being a new teacher without feeling like I need to predict what that means for other new teachers in the population. So there are ways to learn without needing to predict to the rest of the population. Judgment sampling, I'm just making a decision that this is a good place to go to find the data that I need. Quota sampling, I may have decided that I need particular representation. Again, so that elementary, middle, high school, and union versus non-union schools. For our time study is a good example of the quota sampling. I'm trying to fill those quotas. Convenience sampling, probably the worst. We see this unfortunately quite a lot, where because the principal down the street is a friend of mine, I can go to that school whether or not it's my best fit for my research question. Snowball sampling happens quite a bit. Snowball sampling is where we start with some people or some site that we know is relevant, and then we move from that person. We ask for additional recommendations of folks who might be good to sample. So an example here might be, usually this is a more sensitive or challenging population to reach. Say you are interested in surveying drug users. We can go down to a clinic, we can talk to a couple of addicts at the clinic, but then we ask them, who else do we need to talk to about the topic? So that sensitive issue brings us to the institutional review board, and this is part of your badge activity for Unit 5, is to go ahead and do the city training for the institutional review board. This is going to get you into the system at UCB. It's going to cover you in advance for future research designs and access for data. The institutional review board, or IRB, is concerned with legal issues. So any interaction with people or people's identifiable data has to be covered by the institutional review board. Any power relationship or potential power relationship. So key piece here is you don't get to decide if you have a power relationship. The issue is, how is the person, so for example, you could say, well, I'm the principal at this school and I want to do a study of of this school and get data from the teachers who work for me, it may well be that you have no intention to leverage that power relationship, but those teachers might feel like they don't have any option to participate. So IRB's going to want to make sure that you've covered that appropriately. Any minors or members of vulnerable populations, like people in jail, people with illnesses, may be seen as not able to give informed consent. They just don't have either the power position or the knowledge to be able to give that good consent. Talk about consent versus assent. So consent, I remember this always as if you're old enough to be a convict, if you're 18 or older, you're an adult, you give consent, it's on your own behalf. Assent is required for minors or those vulnerable populations when somebody else is given approval on their behalf. They still need to say as an individual that they're good with participating in this study. So it's not enough for mom and dad to say the kid can participate. The kid also has to, their own free will, say that they're willing to do so. Another key thing is thinking about confidentiality versus anonymity. So confidentiality, you know who a participant is, but you don't tell anyone. Obviously, any type of observation or in-person interview, that sort of thing, is going to be only at best be confidential. Anonymous is you don't even know who responded.